So in the last class we started with the arithmetical instructions. In that we studied addition, subtraction, multiplication and division. Also increment and decrement also we studied. So last one we left here, that is the DA. DA stand for decimal adjustment for addition. Listen one, this is the decimal A, decimal adjustment for addition only. So that means here we are making the adjustment. So for which operation? It is for only the addition operation. So in before going to start this one, basically you know that binary coded decimal BCD, that is nothing but binary coded decimal, that is nothing but decimal number we are going to represent in the binary. So that means decimal number is nothing but 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So range is 0 to 9, we can call it as the decimal representation. So what is the binary representation? Is nothing but 4-bit representation we are going to show. So this is 4 zeros. So 1 means 0001, 2 means 0010. So like that, what is the 8 here? 1000. 9 means 1001. So this is a binary representation for this decimal range. So that means we need to observe one more thing. So this representation, it doesn't have the anything the characters like A, B, C, D, E, F. It having only the 0 to 9. So it doesn't have after the 9. That means A, B, C, D, F, it doesn't have. So just careful this one. Second thing is, in BCD there are two types are there. One is a packed BCD, one more is a unpacked BCD. So as by seeing the name itself, we can make the differentiate between these two. Packed is nothing but the digits are somewhat like in packed format. So unpacked is nothing but at the reverse of the first one. It is not like that in packed format. For example, if I say something, the number is 46. 46 is nothing but these two digits are both are decimal numbers. So this is 4 is also decimal number, 6 is also decimal number. Two digits are, it is going to form the byte here. So this one I can call it this a packed number. For other example, 22, 11, 50, 55, two digits are there. So both the digits are decimal number. So this one I can say this is a packed. So for 46, how can I represent in the unpacked? So unpacked is nothing but instead of saying 46, it will come like 04 and 6 is nothing but it will come like 06. That means how to write in binary, it will come this 4. Already I said nibble. Nibble is nothing but 4-bit representation. That means here this is a 0, 1, 00. This is 4-bit. This is also 4-bit. 6 is nothing but 0, 110. This is 40. So this is lower nibble. This is higher nibble. That means by observing this higher nibble, it obviously is consisting the 4 zeros. Obviously it is completely 0. Your number will be in the lower nibble. That means in unpacked BCD, it consisting of all the lower, all the upper nibble. It can obviously it will be 0. Lower nibble will be a decimal number. But in packed, it doesn't have the zeros here. Both will be the decimal numbers. So that means we understood what is the DA and BCD types of BCD, right? But what is the purpose of DA? Decimal adjustment for addition. This is also the instruction, but where we can use it? So problem in BCD addition. So there is one of the problem in the BCD. What is that exactly? So see here. So this is 17 plus 28. So one of thing you need to remember, whatever you are discussing here, this is for the 8-bit data, 8-bit register data. That is nothing but only the 2-bit digit will be there. This is a 1 bit, this is a 1 bit. If you represent 0, 7 means how to represent 0, 111. This is a 4-bit data. 1 means 0001. This is for total 8-bit data we are going to discuss here. Exactly. So here 17 plus 28. 17 plus 28 means how to add here. 7 plus 8 means this is 15. 15 means the hexa equivalent F. 1 plus 2 means 3. So what you got result here? I got the result 3F. But already I said BCD is nothing but consisting of only 0 to 9 representation. It doesn't have anything the A to F. So obviously this result is wrong because F is appearing. So that means it is not the BCD format. So what you can say here, once we perform the BCD addition, results also it should be the BCD format. But it is F is coming, that's why it is not the BCD format. But how can I overcome from that? At the time, what I will do here, 3F, this is the this is your the lower bit. So this is your lower bit. So F is greater than 9. I need to check it. This bit, first bit, it is the greater than 9. At the time, I need to add the plus 6 to this bit. That means 3F, F is here. This is the lower bit. That's why I need to add 06. 06. After the addition, I am getting this is the 45H. So 45H, this is, both are in the decimal format. So that means this is the correct BCD format number. So you take the one more example. Here this is 52H plus 87. So that means here I am getting the D9. So this is 2 plus 7. This is 9 here. 5 plus 8 means 13. This is the D. Here D, 9 decimal number, okay. But this is a higher bit. This is D. D is greater than 9. At the time, here also I need to perform the 06 addition. But D is in the higher bit. That's why instead of taking the 06 here, I need to take the 60. 5 means D is here. That's why I need to add, this is the 60 here. After addition of D, these two numbers, I will get the 139. So that means this is also the 9. This is also the 1. This is 3. These all are the decimal number form. This means this is also the correct BCD format. That means what we can understand here, when you are performing the addition or addition with carry instruction, that means once I done the addition, next, or it may be the addition with carry here, next I need to check the result. Result is nothing but if the lower nibble is nothing but, if I take the consideration here, clear? So this lower nibble means this is my lower nibble. So this is my higher nibble. If the lower nibble is greater than 9, so that means this nibble is greater than 9 here, at the 9, or auxiliary carry equal to 1. Auxiliary carry is nothing but, already you know that any one of the carries coming from D3 to D4, that means D0, D1, D2, D3, that means D3 to D4, or we can say any is carry coming from lower nibble to the higher nibble. That is the condition. If AC equal to 1, add 6 to the lower 4 bits. That means if any carry is coming from here, or other condition, if this lower bit is greater than 9, at the time I need to add the plus 6 here. So that means this is all zeros. This is plus 6. This is 0. This is 6. So that's why I written here, add the 06 here. In other condition, if the upper nibble is greater than 9, upper nibble is nothing but this time. If this higher nibble, if it is greater than 9, or any or CY carry ply equal to 1, that means any carry is coming from the D7 bit. Any carry is coming from the D7, any of the one condition. CY equal to 1 or upper nibble greater than 9. At that time, I need to add the 6 also here. 6 is nothing but, instead of the 06 here, I need to add the, if it is my data, if it is greater than 9 here, at the time I need to add, this is 6, here it is 0. That means here it becomes the 06. If the higher nibble is greater than 9, at the time this value becomes the 60. That is the difference. So take the example here. This is 17, this is 28. So this is a binary equivalent. 17 means I can write this is the 0001. So this is a binary equivalent. 28 means I can represent this is 2, this is the 8. Is it clear? When we are adding addition here, this is a 101, 101, 101, 011, 10. Like that. Here I got the result. Here I need to check. This is the higher nibble, this is lower nibble. Lower nibble is greater than 9. So this is greater than 9. That's why I need to add the 6 in the lower nibble. So what is 6 here? 6 means 110. So here what will happen? 10 means I got 1. 11 means 10. 1110. Again 1 means 11. 1110. Again 11. 1110. Again 1110. Again 01100. That means I got result. This is 4. This is 5. So what we got the result here? Previous it came the 3F, but in the DA, this binary coded decimal doesn't have anything the characters A to F. This is the wrong. I need to make adjustment. How to make adjustment? I need to add the +6. For finally I got this is a 45H. It is in the format, the binary format. So similarly, we take the one more example. Here 52 plus 87. So I got result D9. So check it once. This is the binary equivalent of the first number 52, binary equivalent of the second number 87. Again I need to perform the addition. This means 0 1 1, 1 1 1 0, 1 1 1 0. Again 0 1 means 1. Again this bit is become as it is. So here you need to check. This is 9. This is fine. So this is the D. This is greater than 9. D is greater than 9. At the time, I need to add the 6 here. But this is in the higher nibble. That's why I need to add the 6 here. Remaining is the zeros. So what will happen here? 6 means 0, 1, 1, 0. Here 4 zeros. Again, I need to perform the addition. So 1, 0, 1. So 0, 0, 0, 0, 1, 0, 1. So here 1, 0, 1, 0, 1, 1, 1, 1, 1, 0, 1, 1, 1, 0. So that means here I got one carry. This is 3, 9. So that means this is the perfect BCD format here.